So the following will be today's morning keynote speech. The speaker is Professor Nan Cao. He is from TongJi University College of Design and Innovation. So he's the director of the Intelligent Big Data Visualization Lab at TongJi University. He got his PhD from Computer Science and Engineering at Hong Kong University of Science and Technology. So we're happy to have a Hong Kong friend here. And Dr. Cao also worked for IBM for 10 years. And I noticed that several years of IBM tenure was stationed in New York. He also produced this quite impressive visualization work. Today, we're going to listen to his speech. Okay. Professor Cao.
Hello.
Hi, are you ready? Hi. Can you hear me?
Yes, quite clear. Yeah.
Okay. All right, so I'll give the stage to you.
Okay, thank you very much for the introduction. So good morning, everyone. My name is Nan Cao. I am from TongJi College of Design and Innovation. So it is my great pleasure and honor to be here to have this talk. Today, I'm going to talk something about intelligent visualization design. So some of you may still remember there was an old science fiction movie called I, Robot, which was first shown in 2004, almost 20 years ago. So there was an interesting conversation between Will Smith, the leading man, and a robot.
Robots don't feel fear. They don't feel anything. They don't get hungry. They don't sleep.
I do. I have even had dreams.
Human beings have dreams. Even dogs have dreams, but not you. You are just a machine, an imitation of life. Can a robot write a symphony? Can a robot turn a canvas into a beautiful masterpiece?
Can you?
Okay, so obviously at that age, even in a science fiction movie, people don't dare to imagine a robot can do creativity jobs like drawing a masterpiece or create a symphony. And even for people, it is a big challenge for doing that kind of things. So 20 years passed. I believe Will Smith is still that Will. But nowadays, artificial intelligence techniques are significantly different. They can make designs and do a lot of creative things. So actually, AI programs start creating masterpieces. So you must know this painting, the first AI-generated painting in the history that has been sold at Christie's auction with a hammer price of over 400,000 US dollars. So the signature of this painting is actually the loss function of the generative adversarial network, which is the most frequently used deep learning model in design. So style transfer is another famous example of using AI techniques for graphic design and art. It leverages the convolutional neural network to extract and capture latent style information from an input image and apply it to another image. So this technique nowadays has been widely applied in both design and art. So some more interesting thing will happen when leveraging AI techniques in cooperative design. So in this example, user can create a photo together with AI by just drawing some simple lines and symbols in freestyle. So here is another example shows that even the user don't have any painting skills, he still can generate a beautiful color schema by just simply select some principal colors. As you can see, the color schema is generated in real time and filled in the blanks. You can see the change of the color in this demo, okay? So as we can see, existing AI techniques are already very powerful. However, current techniques still far from enough in terms of supporting design. There are several challenges, including how can we control the AI models to generate more precise results, such as the blueprints, with the detailed skill and annotations. So how to make the AI algorithm or models intelligent enough without relying on a large collection of training set? And also, is there a paradigm of intelligent design that could be applied to all types of design problems? So to explore these questions, in the last few years, we tried to design and develop explainable and controllable AI techniques for supporting a more general design process. More specifically, we would like to train a virtual bot, namely AI designer, that can make sophisticated design efficiently. So we also identified several key design requirements that should be fulfilled. So first, this AI designer should behave like a human designer whose behavior is controllable and explainable. And second, we would be able to communicate, we should be able to communicate with the AI designer to make a cooperative design. And third, the AI designer should be smart enough. It should be able to learn during the design practice so that its skill will getting better and better. So to approach our goal, a reference model for AI-supported design has been introduced. This model consists of 3 key steps. First, we should let the agent understand the design. To this end, we collect a set of successful design works. Each of the design work has been decomposed into design elements and reorganize them into a design space to transfer the unstructured design into structured form. So in the next, we need to teach the agent to make a design. To this purpose, we need to build and train AI models and design algorithms and to learn how to make a design. Finally, we should enable human AI collaboration to let the AI agent make a design together with the human designer. To achieve this goal, new cooperative design tools and techniques need to be developed. Now let's take a look at each of these steps in details a little bit more. So to let the computer understand the design, we introduce the concept of design space. Specifically, a design space is a collection of design elements that are classified by their types. For example, as shown in this video, an elevator consists of 3 types of design elements, including head, face, and body. So the elements from 3-dimensional design space with each element type indicate the dimension of the space. So in this way, an elevator is a combination of different elements in each type. And we can see a design space could be built by decomposing a design work into pieces of design elements and then organizing them by types. So it transforms the unstructured design into a structured form so that a computer program could understand. So it helps making the subjective design process more objective and also makes the design process more interpretable. So in the second step, we would like to teach the agent how to choose the various design elements from the design space to make a design. Here are 3 different types of machine learning techniques could be used. The supervised learning directly learn from the data to find out the innate data patterns, such as the co-occurrence of different design elements, and the frequent patterns of various element combinations, and using the knowledge to make a design choice. The supervised learning uses successful designs made by human designers to supervise the learning process so that the model could learn the knowledge about how to make a good design. And finally, the reinforcement learning uses an action reward model to learn policy of how to choose design element one by one from the design space. It mimics the decision-making process of human designer. So in terms of unsupervised learning in the design field, I think again, the generative adversarial network is the most frequently used. This model consists of 2 parts, the generator and the discriminator. Both of them are neural networks. The generator tries to generate images that are similar to the input samples. The discriminator tries to differentiate the generated images from those real ones. So while running, the generator tries to create images as real as possible to cheat the discriminator. But the discriminator will do its best to differentiate the generated one from the real one. So the model is converged at the point when the loss of the discriminator and the generator are balanced. So here, the design elements are colors at each pixel, and the design space consists of the RGB channels that determines the colors. So actually, this kind of model makes the design at the pixel level. So GAN usually can generate a very amazing result. It is highly creative, which is frequently used for inspiring new ideas. However, the generating process of GAN is usually difficult to control and hard to explain. The generation results are usually imprecise. So in addition, GAN usually generates bitmap images instead of vector illustrations. And the performance is also highly affected by the image resolution. It's kind of a limitation of this technique. So the supervised learning is also frequently used in design. So for example, in fashion design, given a dress, we would like to recommend the accessories that best fit to the dress. To this end, we use a set of clothes and their corresponding accessories selected by designers to train an AI model. So after training, once the user input a dress, the model will recommend the corresponding accessories based on the knowledge it has learned from the training data. So in this example, the design space consists of the dresses and the corresponding accessories. Usually, the supervised learning is easy to control. It is relatively lower creativity when compared to that of GAN, but will frequently generate more precise results. However, the major limitation of this technique is that it highly relies on the training set, which could be difficult to get. So the third AI technique that could be used in design is the reinforcement learning. This technique tries to mimic a human's decision-making process. So in this model, an agent will take actions to change an environment. Each action will get a reward, which is a score estimating how good the action is in terms of approaching a goal. So for example, when the agent is designed to draw a painting, the action will be drawing strokes or fading colors. So that mimics the human painter's behaviors. The environment will be the canvas. The reward estimates how good the current painting looks like after taking an action. So this kind of technique, it is easy to control and explain. I believe it is really a powerful technique that has not been fully explored in the design field. So reinforcement learning can be extremely powerful if the reward and action are carefully designed. This is the algorithm that drives AlphaGo 0 to be the best human player when play Go. It is also the algorithm used by DeepMind to train the AI to be the human player in StarCraft 2. So based on reinforcement learning, as shown in this video, AlphaGo searches through the problem-solving space to make an optimal decision for the next move in purpose of winning the game. So this searching process is similar to a design process in which we will search through a design space to make the best design choice in each design step. So once the agent learn how to make a design, we also need to enable human AI collaboration. Here, besides directly generate the design results, AI program could add the design process by trying to understand the user's design intentions, so that the AI could help finish a task for the designer after knowing what exactly he or she would like to do, just like shown in this video demo. AI is also frequently used to recommend potential design solutions in these cooperative design tools. So this is a general introduction to our reference model for AI-supported design. So in the next, with the aforementioned reference model in mind, in the past 3 years, we have made some attempts to train an AI designer. Of course, this is a very difficult task, and it is impossible for us to make it overnight. So we just want to put continuous effort in this direction and let our AI designer evolve. So we started with a simple target. That is to teach an AI designer to draw sketches. So we chose sketch drawing as our first task, not only because it is a simple task, but also because it is important. So designers often use sketches to record their ideas. When making a design, we believe sketch drawing is actually a creativity behavior that reveals a designer's mind. So to let the machine understand human sketch drawing, we summarize some characteristics of human drawing in process. So first, it consists of multiple steps, and the sketch is drawn stroke by stroke, and only the line matters. That is, we don't need to worry about the filling colors and the textures as that kind of things. So it's relatively a simple problem. So following our reference model, to let the computer understand a sketch, we will first encode each stroke into a vector representation. So after that, we will use supervised learning model to teach the computer to draw a sketch. Finally, we let the model to generate new sketches stroke by stroke based on user's input. So in terms of stroke encoding, a sketch is a combination of strokes. Here, our design space is a collection of strokes, and which is 5-dimensional, to mimic a step-by-step drawing process. So each stroke in the sketch can be represented as a 5-tuple, actually the 5-dimensional vector. So the first 2 fields are the offsets of the x, y directions of the current point from the last drawing point. And the last 3 elements consist of one hot vector indicating 3 different states. In particular, when P1 is 1, it means it continues drawing from the last point. When P2 is 1, it means the end of drawing of the current stroke. When P3 is 1, it means that it is the end drawing of the current sketch. So the P1 and P2 and P3 really records the drawing states. So we use a supervised sequence-to-sequence model to learn the one-by-one drawing behavior of a designer. Here, the model is trained to learn, give a sequence of previous strokes, how can we draw the next one? So once the model is trained, given all the previous strokes, it will automatically predict and generates the next stroke to be drawn. So more specifically, to diverse the generation result, this model follows the variational autoencoder schema and use LSTM as an encoder and a decoder. We also added the attention mechanism in the sequence model and use CNN to capture position features of a stroke. And use a conditional vector to handle strokes in different categories. So to prepare the training data, as I mentioned, this is kind of a supervised learning. So we must prepare the training data set to train our model before we can use it. So to train our data, so we recruit a group of 8 professional designers to manually draw a collection of cartoon faces with 6 different emotions. They are required to draw the 5 scenes separately to construct a design space. So a data set over 5 million facial expressions were later generated by combining all these things together. So actually the data set is open online and everybody can download it now. Here is our demo. So a user just gives some simple input and the AI designer can automatically generate a facial sketch with multiple emotion expressions. Okay. So drawing sketch is kind of a simple task. So in the next, we would like to make a step further by training AI designer to make a graphics design. So in particular, we developed a system called Vinci based on AI Designer version 2. It can generate advertising posters. So in this system, a user can upload a product image. Our system will generate a large collection of advertising posters about the product in an automatic process. So let's take a look at this system.
Vinci is an intelligent design system for automatically generating advertising posters, given a product image and text descriptions specified by the user. Vinci selects design elements that match the product image and arranges them on a canvas to create high-quality advertising posters. We formalize the design of a poster into a sequence of design choices on elements in the four-dimensional design space of the background, embellishments, the object image, and text descriptions. The system consists of four major modules: the processing module, the generator, the reconstructor, and the estimator. The processing module parses raw human-designed poster data, extracts reusable design elements, and transforms the design of posters into sequences of design elements for training the generator. The generator is a deep generative model that produces new design sequences. The reconstructor converts a design sequence into a poster by selecting the proper design elements regarding each of the design steps in the sequence and adjusting the positions of the elements. The estimator is trained to rate the overall quality of the generated poster and output this high quality once to users. Now, let's see how Vinci is used to generate advertising posters. The user starts by uploading an image of the promoted product. Choose a product tab and type in the slogan, promotions, contact information, and product descriptions into the system by clicking the Generate button. The pre-trained generative model at the back end will automatically generate a collection of advertising posters. The posters are displayed in an ordered list according to their design quality rated by a pre-trained estimator. The system also provides comprehensive poster editing functions. The user can switch the poster orientation, resize, and move elements, change text colors, replace embellishments, etc. When selecting an embellishment, the system will recommend similar design elements from the embellishment library for replacement. The user can also undo or redo the operations during the editing process. After finishing poster editing, the user can click on the Update button, and an online editing feedback mechanism will automatically analyze the editing operations to learn the user's design preferences. As a result, all posters generated previously will be updated to meet the user's preferences. Finally, the user can choose the satisfied posters and download them by clicking the Download button.
So based on this system, we perform an interesting Turing test. So in this experiment, we first prepared 10 product images and asked a group of 10 human designers to design an advertising poster for each of the product within 1 hour. So we also generated 10 advertising posters respectively based on Vinci and Luban. And Luban is another poster generation system developed by Alibaba, the biggest e-commerce platform in China. So here is the result. A product image is shown in front of each row and followed by 3 advertising posters designed either by human or by AI. So can you make a guess which column is created by human designer and which columns are generated by the AI? So I think it is not difficult to find the posters designed by human with putting all these posters together. So you're right, the first column is designed by our designers, and the rest 2 columns are actually generated by the AI systems. So in our experiment, instead of showing all the results together at the same time, so we show 1 poster at a time to a participant and ask him or her to tell if the poster is designed by a human designer or by the machine. The 100 participants were involved in our experiment. Here is the results. About 60% of users is able to correctly identify the posters designed by human designer. And over 80% of users is able to tell the poster generated by Luban is not designed by human. Actually, that is less than 20% of users think the poster generated by Luban is made by human. However, it is not easy to make a clear judgment when using our system. About 40% of the users think the poster generated by Vinci is designed by a human, which is actually wrong. But it also shows that our system has successfully cheated 40% of the participants, which passed the Turing test. So Vinci actually is not the end of our story. We keep working on improving AI designer. Then we have the third generation, which is able to design data visualization charts. So it is much more complicated as when we take data analysis into consideration, the design space will become more complicated. So data visualization is an interdisciplinary field, which is a combination between information communication design and the data science. It studies about how to transform data into a visual representation. So this figure gives the reference model for information visualization. Generally, it takes 4 major steps to transform data into visual representation. First, the data need to be pre-processed to eliminate data noise and transformed into abstract form. Next, we need to make the visualization design to represent the abstract data. The design will determine how to represent data elements and their attributes by graphical symbols such as points and lines, and their visual attributes such as colors and size. We also need to compute the position of each node and link so that the visualization could be clearly rendered and displayed on the screen. So finally, the results are displayed on the screen as a visualization. So generally, we design data visualization for 2 major purposes. The first one is to support interactive data analysis, and the second one is to support information communication. That is to help with data narrative or telling a data story. The second one is our focus, as it is the key to information communication design. So what is a data story? So let's first take a look at one example about data story.
Imagine there are only 100 people in the world. Who are they? 86 people can read and write. However, 14 are illiterate. 78 people have proper houses. 21 don't have adequate housing to fully protect themselves. 1 person is homeless. 65 people are cell phone users. 35 do not have a cell phone. 47 people are internet users. 53 have never been online. 68 people have improved toilets. 18 have unimproved toilets. 14 don't have access to toilets. This is who we are. Imagine our world 50 years from now. What would you want it to look like then?
So as we can see from this example, visual data story is actually a series of meaningfully connected story pieces known as data facts. So that are represented in form of narrative visualization charts. So to create a visual data story, one needs to learn a lot of techniques such as data analysis, visualization, and scripting, which are not easy for ordinary users. So our question is, given a data set, is there a way to train our AI designer to automatically generate a visual data story to help with the narration of data insights and information communication? So to answer this question, we need to understand how a data story is created by a human designer. So to this end, we collected a set of 230 high-quality data videos, which are manually labeled and divided into 4,186 story pieces and 2,583 data are related with data, which is known as data facts. So this gives us a data set based on which we made a series of deep analysis and detailed investigation. Okay. So based on these data facts and the story pieces, a number of interesting findings that are critical for generating data story were identified by us. So for example, we identified the frequently used data facts and the narrative logics. And we also identified a set of frequently used visualization chart in data stories. So doing this kind of thing will kind of limit the size of our design space, because if the size of design space is too large, it will going to be very difficult for us to make a certain kind of automatic design. So we also investigated several critical design problems based on the data set and constructed several design spaces to help us understand a number of important data story design methods. So this including how to deliver message using animation, and how to use visual embellishment to decorate the chart to support the data communication, and how to deliver message using illustrations, and how to make a smooth data transition between different story pieces, and how to create a story by following a narrative structure, and how to express positive and negative emotions when telling a visual story. So to verify the correctness and effectiveness of these design spaces, so we have conducted a series of visualization design workshops. So during the workshop, we teach the participants how to use our design space to make a visualization design or data story design. So the users' feedback were carefully collected, which were later used to help improve our design space. So actually, we made a series of workshops. This video shows one example of our workshop. Most of the participants are the professional designers. Okay, so our work about design space has been published in a number of top conferences, including ACM Chi and IEEE in this year. So these publications became the theoretical foundations of our intelligent design research. And we hope that this design space could be used as a general tool for supporting more advanced visual communication design. So with all the design spaces in hand, we now design and developed a data story generation engine based on the reinforcement learning. In particular, a parallel multi-color tree search algorithm has been introduced here. It searches through both the design space and the data space simultaneously to construct a series of related data facts that are shown in charts to generate a data story. So during the searching process, we will generate a visualization chart to illustrate a newly created data facts. A visualization linter and fixer is also developed, which can automatically check the generated visualization design and fix the design errors when the design violates certain kind of design principle. So we made this library open source. Nowadays, you can download this kind of a powerful design checking tool online. So to support the cooperative design, an intelligent star editor has been developed too, which supports interactive editing and visualization charts recommendations. As you can see here, we can actually edit the caption of each data facts. And we can also change the order of the data facts. And also change the chart types and doing all kinds of things that you want to do in this tool. So as a result, all the aforementioned techniques has been integrated into an online system called Calliope. It is an intelligent tool developed for data story generation and creation. Let's take a look.
A visual data story is a series of meaningfully connected story pieces known as data facts represented in the form of narrative visualization. To generate a visual data story, one needs to learn a lot of techniques such as data analysis, visualization, and scripting. To lower the technique barrier, we introduced an intelligent system, Calliope, to generate visual data stories directly from an input spreadsheet in a fully automatic process. The system incorporates an efficient algorithm that explores a large story design space given by the input data to create a meaningful and informative story. In this video, we demonstrate the process of generating a data story using Calliope, which is easy and simple. A spreadsheet containing the records of 1,234 startup failures in China is used in our demo. Each startup company in the data is described from 6 criteria, including its broken year, location, industry, funded status, survival time, and the main cause of failure. We upload the data into the system. After clicking the generation button, the story generation engine is turned on and the intermediate results are updated in real time on the user interface. In this view, we can interactively add or remove a chart, change its logic order, or edit on its caption. We can also revise the data content and visualization methods of each data fact in the fact view when necessary. 3 visualization modes are provided in Calliope to help represent the generated story in different devices. The storyline mode fits well to the screen of a tablet or a laptop. The swiper mode facilitates the story exploration on a smartphone. The fact sheet mode shows the story as a poster that can be easily printed out. A user can also share the generated story with their friends via a link by clicking the share button. Now, let's take a look at our story that is automatically generated based on the aforementioned data. It shows that a lot of companies died in recent 3 years, and most of them were located in Eastern China. The most dangerous fields were e-commerce, social media, and local business. Most companies dead in these fields were still in the early stages before the Series A+ round, and some are even dead without getting any investment. Regarding the reasons, no business model and no market need are the most frequently occurred problems in these startup companies. As we can see, using Calliope, a good visual data story is just a click away from us. Now the system is free, available at datacalliope.com. Have fun and enjoy yourself.
So actually, we have launched this system at the end of last year. So until now, there are hundreds of data stories that's been created by our users. And you can also have a try via this link. So far, we have introduced our journey of training an AI designer. However, the evolution of our AI designer is far from ending. There will be more coming soon. So you must know Atlas, developed by Boston Dynamics. Since the first version launched in 2013, after 8 years evolution, nowadays this robot can do really amazing things. So we hope our AI designer can also evolve in this way and can finish more complicated design tasks in the future. So we hope the next version of AI designer can do more complicated data analysis and generate more precise design results, and can handle design problems such as draw blueprints or build a CAD model. So let's wait and see. Thank you. That's the end of my talk.
Thank you, Professor Cao. We already got a few questions. So the first question is, so I'm going to just repeat it. Great lecture. Quick question. Is the design space accessible to the public, or it is still in the working progress? So I guess this audience is asking the design space you mentioned there.
Yeah, actually, the design space is a concept. It contains a lot of things. For different design, it may have different design spaces. We do publish our design space online, and we also published our design space in a number of top conferences. So maybe you can read our papers, and also you can find a link in the paper and open this tool. You will find the detailed design guidelines about how to use our design space. It's a free online currently.
Okay, thanks. Another question from Susan. Why have you called this an intelligent system? How appropriate do you find that terminology? I guess that's a very common question in design field, right? When you talk about intelligent, what does it really mean?
So for me, actually, I mean, intelligent is that it's not a human intelligence, it's machine intelligence, it's artificial intelligence. So if we design something based on machine and it's generated by machine, or the design solution is recommended by machine, I call it intelligent. If the decision is made by human designer, I will say that that system is not intelligent. So for example, nowadays, I know the Photoshop is kind of smarter and smarter. They can do a lot of things for the designers. But at the same time, you must make the decisions for when you're doing some kind of design. So I don't think the Photoshop is a fully intelligent tool, but it's kind of contains some kind of intelligent functions there. Yeah.
Okay, I guess the key point here is decision making, right?
Yes,
okay.
Exactly.
I would like to take some questions from the floor.
Hello, thank you for your presentation. I just have a general question about what your definition of design is, and also when you talk about decision making, how broad is the possibility? Because I noticed that you used a lot of like frameworks, like narrative development and all that, but within that, I feel like in a way you're limiting the decisions that human designers can make. So I'm just wondering, yeah, what your definition of design is and how broad is the possibility of decisions that can be made. Thank you.
So actually, this is a good question. So this is a very difficult question for me to ask because I'm a kind of a computer science people. And based on my understanding, what we are trying to do recently is trying to simplify the design process, which means that we are trying to understand the design from the viewpoint of a machine. So how can a computer understand a design? How can the computer make a design? So for me, the design is really the combination of all kinds of design elements. This is definitely a very, very narrow definition of design. I'm sure design contains a lot of more things than what I said. But from the point of the machine, I mean, from the point of an AI program, so we are trying, if we want trying to understand the design, the first step we are going to make is trying to decompose the design work into pieces so that the computer can read the information into the memory and doing some certain kind of computation. So this is what I understand the design from the view, from the point of a machine. So, and in terms of the second question, could you repeat that? Oh, Q2. So.
I think you were talking about decision. So what does it really mean by like a decision? What kind of decision, right? Yeah.
Yeah. Like how broad is the possibility?
Yeah, got you. Thank you very much. And for the decision, it's really about for the design decision. It's really about the design actions you are going to make to finish your design work. For example, you want to drawing a line when you're drawing a sketch, or you want to choose a color when you're drawing painting, or you want to, for example, using a certain kind of a 3D model in your CAD blueprint. And those kind of things, the decision, it's usually made by a human, you know, so because the human designer knows how to draw a sketch. So he or she decide how to draw each line. So this decision, we call it design decision. And we want the machine to learn this kind of decision process, which means that we want the computer can think like a human being. So that once you do some kind of operations, and the computer will guess what is going to be the next. And it will help you to make the decision what is going to be the next. So the really kind of things in the computer world is kind of the decision is really kind of actions that you make by the designers.
We
Yeah, I
have
hope
many
I have the
questions.
microphone.
Okay.
Yeah, I'm kind of like a robot, but I'm currently thinking that way. Okay.
Okay, yeah, well, someone already got a microphone.
Yeah.
Okay, Sylvia.
Yeah, thanks, Professor Cao. Very good talk. We understand your work is more like to contribute to establish a kind of the basic tools or the principle how a designer can use AI as a tool to facilitate their design work. But my question is, always we have this kind of the discussion, how you define the scope of the design space. So we know the difference between the qualitative and quantitative things, right? For the quantitative, when you're talking the big data, then the source of the data is very important. So when you select the design space, that is also mean you control the scope of the variables. It means that you control the limited source of the data. So my question is, when you comes to design the space, that is also the limitation already. So how you can solve this kind of the problems? Because when we're talking design, it's all about the imagination, the endless, those kind of the scope. So this kind of the debates, and how you can solve that in your research?
Yeah, actually, okay, thank you. That's a really good question. And we do think about this problem because, currently, as I mentioned, we want our AI designer to evolve. So currently, the function we have implemented is still very simple. And so we kind of limited our scope a little bit. We're trying to make our design space as small as possible so that kind of our searching algorithm can do an efficient way to come out a certain kind of design solution. So way that we used here is that we're trying to give a design space based on design tasks, which means, for example, if you want to make if you want to design poster, so we will construct a poster design space. So if you want to design visualization chart, so we will construct a visualization design space for visualization chart. And if you want to do some dynamic chart, or dynamic illustration, so we will focus on the dynamic part, the animation part, how to make the animation on the chart or on the illustrations. So that will give a very strict kind of a scope for building up our design space. And you're right, there are a lot of kind of subjective things here. And you talk about creativity, and we do realize that design space will limit the creativity of a generated design result, or generative process. So we don't find a real solution for this problem. But the current focus of us is just trying to improve the efficiency of the design process. At the same time, you provide certain levels of creativity here. And so actually there is some very interesting research we have done recently that we're trying to understand how to use visualization charts to express emotions. So this is kind of very subjective topic. So because the emotion is kind of it's not that objective and it's not that computational. So even that kind of topic, we do find a design space. We do find some kind of parameters that can control the visual representations that will affect a user's feeling, emotional feeling. Okay. So I think there's a lot of solutions and there are a lot of things we still need to study. For doing that kind of thing, we need to do a lot of user studies. So and do a lot of deep research, I believe. Yeah, that's a very good question. I think we definitely should think about that, that kind of things in the future. Yeah.
Thanks, Dr. Cao. We do have overwhelmingly large number of questions. So next, Gio.
Yes.
From the spot. Yeah.
Hi, this is Gio from Hong Kong Polytechnic University. Thank you for the presentation. I have maybe one question about the latest advancement in image generation, and typically image generation from text. I'm sure you know about clip and DALI project from OpenAI. I would like to know from you what's your opinion on how does the future look in terms of this type of technology where I can simply type an idea and generate an image. Is there space in what you're researching for this type of technology, and how do you see it moving forward in the future? Thank you.
Okay. So I can see this is a very promising direction and a very interesting direction. I mean, input text and generate a certain kind of image. And it's really kind of a creativity things, and it will inspire some new ideas. And but for the problems we are trying to solve is that we generate precise designs. I mean, precise is that, for example, blueprints with skills and detailed annotations on it, which is once you generate it, the blueprints can be printed out and just be used by the engineers to build something. So this kind of a generation, but you know, it's kind of a currently we generate image. It's kind of a fuzzy process. You can tell the image what you want to do. For example, you want a bird with a red head, so it will give you a bird with a red head, but it's not precise. But still, it's very creative. It can give you hundreds of different kinds of birds there. So this kind of a result will inspire some new ideas. I believe it's very interesting, and we also do that kind of research, but we didn't present this work in my slides. But we doing that kind of thing. But again, we based on the design space model. We are not trying to generate an image from the pixel level, because that is not a vector illustration. So we do it in the design space model, at the design space level. So we do some kind of a combination of the design elements and generate that kind of things based on the input text. Maybe I can show this work in the next time. Yeah.
Okay.
Thank you.
Thanks. So the next question from the audience is, design trends and styles change constantly. In a speculative future scenario, how do you think a designer AI would keep up to date with the latest developments? I think this is talking about the context, right? How sensitive your AI designer is to the context, right? And trends and styles.
Yeah, very difficult. Very difficult. This is really a challenging task. It's kind of nowadays we just let our AI designers learn to behave by how to become a human designer. It's learn from human being. But it cannot really create at the current stage, It's kind of maybe in the future we can do that, but at the current stage, and I don't imagine and we can achieve that goal in a very short time. But I'm still have a hope that we can do that maybe in the next 5 years, and trying to kind of generate future design solutions for certain kind of things. That really depends on what kind of design you want to make, and there are so many different types of design, and our research currently mainly focus on the visualization design. I mean the visual communication design kind of things. But how can we solve another types of design problems? We haven't had a chance to try that yet, but we'll do that in the future. Thank you very much for the good suggestion and question.
Okay, more work, right?
More work.
More work.
Yeah.
So there's a question from our Zoom audience. Where is the step in between parametric design and the AI design you have shown? What makes the difference?
Yeah, the difference actually is very obvious. For the parametric design is that we write a program, and there are some parameters that you can tune, but the program is fixed, and the generation result is fixed. The only changing thing is the parameters. Once you change the parameter, the generation result will change a little bit, but it's still under the framework, under the structure of the what is defined by the program. But for the intelligent design, it's kind of the intelligent program can create something that never happened before, which means that when you build an AI model based on deep learning, they do have a lot of parameters, but at the same time, it will try to generate something new. which is beyond the scope of your input data. And this is kind of cannot be achieved by the traditional pyramid design, I believe. Yeah.
Okay, I think that's pretty clear. We have more questions from the floor. Can we pass the mic, Clifford? Okay. So
okay,
Clifford,
so
please ask.
your research on the data story is really interesting. So I look at this as a very interesting research question. So I have a question about how to prioritize different data. You call it the story piece, right, or the data piece.
Mm-hmm.
So because different people have different emphasis. So for example, if I sell something to a housewife, maybe I emphasize on some price, right? If I sell it to our boss, right, KP, so it may be more on the cross
yeah, I know. I got
thing.
your point.
So,
yeah.
so it seems like, I'm not sure, in general, this is about design intent. So how can you model design intent in a more abstract way? Yeah, sorry. That's my question.
Yeah, this is a very good question, which I didn't mention in my talk. So you give me a chance to give more details about my work. Thank you very much. So for the design intention, it's always given by the users. So actually, to generate data story is a really complicated things. We have a module called topic analysis, which means that the user could give a certain kind of a topic, and we will analyze the data to extract the data facts that are corresponding to the topic given by the user. So usually the topic is given specified by the data columns, because currently our generation engine takes a spreadsheet as the input, which means we take an Excel table as the input. Then the kind of the topic the user may interest in could be some certain kind of top columns inside the spreadsheet. So the user will tell us which columns are you interested in most. So we will focus on these columns to generate those kind of data facts and build a data story. So at the same time, we will also analyze the data set automatically. So during the analysis, we're trying to figure out what kind of information is contained in this piece of data. So this is very important. We use the technique called so-called is kind of automatic insight, auto insight. So it will find the most important data facts automatically from the data from input data spreadsheet based on information gain and also information quantity. I mean the information theory kind of things. We will rank those kind of data facts that we generate and pick up those kind of most informative ones to help us generate a story. And of course, all these kind of generated data facts will relate to the topics given by the users. Sorry.
So, so it sounds like the design intent is kind of implicit, right? And kind of inferred from what kind of data and what kind of information you have. So I think it's more at an implicit level, right? At current stage.
Yeah, actually, so we allow user to give a natural language input, and we parse the natural language and mapping them into our data set.
Okay.
And then doing the automatic analysis.
So I guess that's another way to kind of take the intention from the human designers, right?
Yes.
So it's also possible using natural language. So I remember there's more questions. Kriti? Ray?
Yeah.
Okay.
Hi, Professor. Thank you very much for your interesting talk. And I'd like to ask two questions from two perspectives. The first one is from the technical perspective. Yeah, we've seen your exciting work. Yeah, you generated those novel design samples from those input data. But yeah, to my best knowledge, yeah, as I also came from computer science background. So I think these AI-generated design samples are basically trying to mimic those input or those training data, right? And for this reason, it can have a very a limited opportunity to produce those novel ones and creative ones where our human designers or the real world indeed request for. So my question is, maybe you can propose, maybe you can give us the example of the AlphaGo, because okay, AlphaGo can come up with some strategies that human chess gamers can never think of. But AlphaGo is based on reinforcement learning, which is based on the final outcome, whether win or not. There's a very there's a very rigorous rule there telling me if this win or not win, how the coefficients should be adjusted accordingly. But if you'd like to use reinforcement learning to solve the problem of the limitation those conventional machine learning methods would encounter, this is not workable from my perspective, because whether design work is good or not good is totally unlikely to the case of the AlphaGo case, win or not win, because good or not good is very subjective. So do you think it is possible to solve this issue from a more advanced machine learning or reinforcement learning approach? That's the first question from the technical perspective. The second question is from the design perspective, because we know that up to now we have yielded many interesting results, but it seems that we haven't really incorporated these works into the actual design pipeline in our industry areas. And what's more, I still think, as our professor has mentioned, that our machine learning is trying to build up a model that considers several coefficients and consider the final output to try to find a design space based on the data you collected. But these are limited. These are trying to limit the possibility of design, the design possibility. Do you think that the human factors and the model you build should be studied as a whole to build up a so-called human-computer collaborative design mode? Thank you very much. Sorry for my question, it's a little bit lengthy.
Those are really big questions. Do you still remember it, Professor Cao?
Yeah, I got his points. It's a very good point. And I like to talk to the computer science guys. And so actually, for the first question, is that there is no good and bad in the design space. It's very difficult to make a judgment, right? So that maybe the reinforcement learning is not that efficient when you apply the kind of techniques when making a design. So you're right. So there is no good design or no bad design. It's very difficult to make a judgment about these kind of things. But we do have certain kind of goal to reach. For example, for building a data story, we do have the information we want to deliver. So one goal we're trying to reach is that can we just deliver all the message that we want to show to our audience? If we have done the stories, we have finished the generation of the story. And also the story has we must follow certain kind of narrative structures. So for example, it will have certain kind of introduction about the background of problem, the problem background, and also it will have a certain kind of certain kind of problem questions, and also give you a certain kind of conclusion. So it will follow certain kind of structures. So we can also terminate our generation process if the story has been really complete. I mean, fulfill the certain kind of structures. And we can also do a cooperative design kind of things. So we will let the human to decide each of the design step is good or not. So once you, in this way, actually, our tool is kind of recommend certain kind of design choices to the designers. So the designers will make the final decision to use it or not. So in this way, we leave the judgment, or we leave the goal, leave the target goal to the designers. So ask them to help us to make a justification about our generation results. So in this way, we still can use reinforcement learning kind of things to build our design. So this is for the first question, but I believe so reinforcement learning is really kind of a promising technique that has not been fully explored in the design field. And our lab is trying to do more research in this direction as well. And we are trying to use all kinds of reinforcement learning to solve more complicated design problems. For the second question from the human side and the human AI interaction, right? Human AI collaboration. So could you repeat that question again? A little bit forgot.
I think the question is kind of general, right? So just how you consider the human factors, how do you input them, and currently from the status quo, the AI design hasn't really gone into the real world design pipeline, right? So what is your vision or envisioning of this, right? Since it is not really happening around us.
Yeah, actually, I believe it's already happening around us because I know the Adobe nowadays has integrated a lot of intelligent functions in their Photoshop and related products. So it will help people to more efficiently work on a design job. So I believe human AI cooperative design is really the really the future of AI design. Okay. So we must make our model interactable and make our model be able to collect users' feedback and understand users' design intentions, making smart suggestions. So I think that's the direction. Yeah.
Okay. I think we have 7 minutes left. I would like to take a Zoom question. We have a competition for questions. So. Kriti, okay, and then the Zoom question. Just be short.
Thank you.
Hopefully, we can have 2 questions answered.
I will just be very quick and brief. And this is a question which has been asked several times to many people who are working in the field of AI. So I would like to know from you that with the emergence of AI designer rather, how does it impact the role of human designer and design education? And then I was asking myself, then is the role of human designer to teach AI designer? I mean, is it going to be limited to that?
Yeah, I agree. That's a very important question. I always have that question to myself too. So what is the role, right, of AI designer? What is the role of real world designer? How do we positioning everyone?
So actually for me, the AI designer is really an assistant. It's doing something that a human do not want to do. I mean, those things are very tedious and time-consuming and not that creative, those kind of things, because machine is more efficient than people, but people is more creative than machine. So for me, so we really want to make the AI designer as a certain kind of assistant that could help the human designer to make a better design within using a short time.
Okay, I guess that's a kind of a simple and straightforward answer, and we can think about actually many possibilities along this straightforward direction. Okay, I really want to take in another question that is from Zoom, from Lai. Thank you, Doctor, and very inspiring webinar. In Calliope, the data stories, the storyline seems to be visualized more from the God's eye point of view. How do you consider the data story can guide the general users to interpret their stories? Or do you consider the data storytelling process from the human cognition process aspect? So I think it's more about in the background, right? What kind of strategy you use? Because you did mention narrative, not logic, right? But this is a good point that how do you decide on the perspective? Or in your storytelling, have you actually considered the perspective?
Yeah, so actually we do consider about perspective. So usually we are trying to develop a tool for creating the data stories. So for that tool, and we're trying to make our user as a people who want to create a data story. So that's really kind of a God perspective, which means that you decide what kind of content could be shown inside the data story. And you decide what kind of visualization representation style could be used there. So in terms of the audience, and we didn't have too much work and from the audience side kind of things, but we do trying to understand how audience will accept the knowledge or accept the information inside the data story. And we're trying to maximize those part of information when we're creating a data story and deliver it to our audience. So that is what I just mentioned, that we're trying to compute the information quantity for each of the data facts that we choose inside the data story, and trying to deliver that kind of piece of information to our audience. And that's really currently what we have done. And you give me a very good points. Maybe we should think about different perspective and different users and target on different users. Yeah, that's a very good point. We haven't done too much work on that yet. And thank you very much for your suggestion. Yeah.
Okay, thank you. So 5 minutes. Do we want to take in one last question from King? You want to do it? Oh, you already have the mic. Okay, from our spot.
Okay, my question is just factual questions. I'm very curious of what kind of expertise you are collaborating with currently in your lab.
Okay. So actually, this is also a very good question. So my lab has two kinds of people, every three kinds of people. So one is the designer, of course. We have a lot of students and from the design college. And we also have some students from the mathematics school. So they are the guys who are building the AI models, kind of things. The third group of people, students in my lab, is from computer science. They are building the AI systems. So for example, our Clarity system, the online system built by those group of people. So we are trying to leveraging all kinds of skills and all kinds of techniques together and combine in my lab. So it's really interdisciplinary, and the designer actually plays an extraordinarily important role in my lab, because usually the designer tells us what is important, what kind of decision is important when you're doing certain kind of design. Because including myself, I'm not in background of design. So actually, I'm trying my best to learn and to view from the perspective of a designer, but actually I'm not a designer. So I really kind of rely on those kind of real designers to give us some hints, give us some guidance about how human can make a design. So they are very important. And for the mathematical people, they're building AI models that can mimic the design behaviors in a design process. And then we build the AI system altogether, integrate everything together based on the computer science technologies. Yeah.
Okay. Do we have time for one quick question? Because there is a funny question there. So I just want to end with a fun question. So this is a question from Zoom audience. So it says, humans get bored easily and naturally. Can this AI designer take into account the response to human boredom?
Okay, that's I think that's difficult, and okay, we will try, and maybe this is a good points as well, and how to take this kind of feedback into consideration when we're making artificial intelligence design. Yes,
yeah, I think it's interesting because in game design, right, a lot of games actually already taken into the response of human boredom, right? So they create games out of it. So I think we're really running out of time, and totally we have so many questions, and I actually have a suggestion. We will send you a Discord invite, and I really hope you can join our Discord space, and I would really like to extend this discussion onto our Discord channel. So we actually do have a channel set up in Discord for each keynote. So we will be in touch. We send you the link. If you can join the space, that'll be great, because AI and design is a really hot topic. So, and in School of Design, PolyU here is actually a very much debated topic. So we actually have a lot of questions from the floor that I couldn't take in. So I would really love to see we can continue this discussion based on your presentation today. Is that okay?
Okay, thank you very much.
Okay.
Yeah,
Thank
sure,
you.
I will be there. Yeah.
Okay. Thank you. So this concludes our keynote. Thank you, Professor Cao.